Welcome back, and let's continue with our lesson on number patterns. So we are now going to be focusing on the first section of our lesson, and that is investigating and extending numeric patterns. So let's extend the following numeric patterns. We have here 2, 4, 6, and 8. So can you see how we move from the first term to the next term? If you are saying that we are adding 2, then you are absolutely correct. So we are just adding 2 for us to get to the next term. And if I were to extend this pattern, then I would continue and say that the next term is 10, the next one would be 12, the next one would be 14, and you can continue that pattern. Do you notice that there we have a constant difference, meaning a difference that is the same? And how did we find that difference? We said that our second term minus our first term. So 4 minus 2 is 2, and then, but also 6 minus 4 is also 2. So that is our constant difference. Let's look at the next one and see how we can extend this pattern. So let's investigate what is going on here. So if we look at this pattern from 1 to 2, or even better, to find the difference, we say that the second term minus the first term. So 2 minus 1 is 1. When we move on to the next one, we have 4 minus 2, which is 2. Can you see that the difference there is no longer constant, but it is still a pattern? So let's investigate what is going on here. So for us to get to the next one, we say 7 minus 4, which is 3. Look at the differences that we found there. Do you think you can calculate what the next term will be? So we started by adding 1, then we added 2, and then we added 3. So the next one, yes, you are correct. We are going to add 4. So when we add 4 to 7, we are going to get 11. The next one, we are going to add 5, and that is going to give us 16. And the next one, we are going to add 6, and that is going to give us, yes, 22. And again, you can continue that pattern however way you like. Let's move on to another pattern. We are still investigating and trying to figure out what is going on in this pattern. So let's start by finding the difference. So 3 minus 1 would be 2. And then 6 minus 3 would be 3. Again, the difference is not constant, but let's see if we can find a pattern here. 10 minus 6, that is 4. So do you think you can figure out what is the next term? While you are thinking about it, I want you to notice here that from 1, we added 2, and that gave us 3. Then, for us to find 3, so 3 comes from 1 plus 2. And then, when we get to 6, 6 actually comes from 1 plus 2 plus 3. When we get to 10, 10 actually comes from 1 plus 2 plus 3 plus 4. So, what do you think the answer will be when we say 1 plus 2 plus 3 plus 4 plus 5? Yes, you are correct. The answer is going to be 15. When we add the next one, which is now going to be a plus 6, we are going to get an answer of 21. And when we add the next one, which is a plus 7, we are going to get an answer of 28. So that pattern, again, can continue whichever way you like. So when we are looking at the next one, let's look at what the pattern will be here. So we are going to do what we've always been doing. 1 minus 1 is going to be 0. 2 minus 1 is going to be 1. 3 minus 1 is going to be 1. And 5 minus 3 is going to be 2. So you are looking at it here, and the difference doesn't have, first of all, it's not constant, and it doesn't have a pattern like our previous patterns. So what do you think is going on here? So what we've written here is not a difference or a constant difference for us to find the next pattern. But look at it more carefully. What do you think is going on there? Let's look at this 1. If I say 1 plus 1, that gives me 2. And if I say 1 plus 2, that gives me 3. Can you see how we are adding the 2 previous terms to find the next term? So I think now we're in a better position to continue this pattern. So let's continue and add them. So 1 plus 1 is 2. We have that. And then 1 plus 2 is 3. Then 2 plus 3 is 5. How are we going to get the next one? Yes, we are going to say 3 plus 5, and that gives us an 8. And for us to get the next one, we are going to say 5 plus 8, and that gives us a 13. And how do we get the next one? That's going to be 8 plus 13, and that will give us a 21. Again, it is a pattern. You can continue with that pattern however way you like. 8 plus 13, and that is going to give us a 21. And again, you can continue that pattern indefinitely. Let's continue to the next focus of our lesson, and that is representation of numeric patterns in tables and algebraically. We are going to look at that first pattern that we did in the pre-knowledge practice questions. So we had 5, 7, 9, 11, and we continued the pattern with 13, 15, and 17. If you remember, our rule there was that we add 2. So we are just going to represent this pattern in a table. So the first number or the first term is 5. The second one is 7. The third one is 9. The fourth one is 11. The fifth is 13. The sixth is 15. And the seventh term is 17. Now, what would the 20th term be? We cannot go on counting until we get to the 20th term because we can see there's a very big gap between 7 and 20. This is why we need an algebraic representation. So here's the table as we filled it out. And we can see there that the answer for the 20th term is 43. But the question is, how did we find that 43? We need to find the relationship between the term number, which is the one up here, the constant difference, which is that 2 that we were adding, and also the term itself, which in this case is the 5, or the 7, or the 9. So we need to find a relationship between those those 3, before we can find the 20th term. So let's look at this pattern, which is 5, 7, 9, and 11. And this will be the rule. We are going to take the constant difference, multiply it with the term number, and then we are going to add 3. Let's look at where this 3 comes from. So we are going to say the difference multiplied by n, which is the term number, and we are going to add 3. Our difference here we saw was 2. We are going to multiply that by n, and then we are going to add 3. Let's look at where this add 3 comes from. If I'm looking at the first term, so remember this was the first term. The term number is 1, the term itself was 5. So if I say 2 multiplied by 1, remember the 2 is the constant difference. I'm multiplying it by 1 because 1 is the term number. What answer does that give me? That gives me a 2. But now I need to see how much I must add to get to the first term, which is 5. So if I have 2, how much must I add to get to 5? You are correct. I am going to add 3, and that gives us a 5. Now to check if this is the same with all the numbers, we are just going to take the third term here, which is 9. So I'm going to take the constant difference, which is 2. I'm going to multiply it by the term number, which is 3. And then our rule says we are going to add 3. Let's see if it will give us our actual term, which is 9. So what is 2 times 3? It's 6. And then when we add 3, that's going to give us a 9. So this is how we are going to represent our rule. It's going to be 2 multiplied by the term number, which is 2n, and then we are going to add 3. And we can see that our rule actually works. And if you want to test it one more time, you can take the fourth term there and say that's 2 multiplied by 4, because that's our term number, and then we are going to add 3. And what is 2 times 4? It's 8. And then when we add 3, that gives us 11, which is the term number itself. But remember, we are now looking for the 20th term. So how are we going to work with the 20th term? We're still going to use our rule. Our rule or our formula says that we should take 2. We are going to multiply it by 20 because I am looking for the 20th term, and I'm using brackets to represent that 20. And after that, I'm going to add 3. So what is 2 times 20? You can now go ahead and actually punch that into your calculator or use a little bit of mental maths because you already know how to do calculations with integers and whole numbers. So what is 2 times 20? That is 40. And when we add 3, our answer there is a 43. I really hope you got this one. But let's look at another example, still the same example that we looked at before. So when we look at the rule in words, we say here that we are counting in 5s because remember the difference was 5, except that we have started there at 4. So from 4, we are counting in 5s. Let's fill out the table and see what we get there. So from 4, 9, 14, let's fill it out there. The second term is 9. The third term is 14. The fourth term is 19. Remember, we are counting in 5s. So when we continue this pattern, we are going to have our 24. Then we are going to have our 29. And we are going to have our 34. We had already calculated the next 3 terms for this pattern. But now what is the algebraic equation? Because when we have big numbers like the 20th term, the 30th term, the 100th term, then we need a formula to represent these. Do you remember how we are going to find the formula? We said we are going to take the constant difference. We are going to multiply it by the term number, which we use n to represent that. And then we are going to see what we must add or subtract so that we can get to the first number. So let's do it. Remember, our constant difference is the 5. And I'm going to multiply the 5 with 1 because we are now working with the first term. And then 5 times 1 is 5. Now I have to see what I must add or subtract to get to the first term, which is our 4. So I have 5 and I need to get to 4. So from 5, how do I get to 4? Yes, I must subtract 1. But now to check if this minus 1 is the correct one, let's just work with the second term as well. That is going to be 5 multiplied by 2 because that is our second term that we are working with. And then 5 multiplied by 2 is 10. But now from this 10, I need to get to the second term, which is 9. And how do I move from 10 to 9? Yes, you are correct. I'm going to subtract 1. So this means that our rule or our equation here is going to be Tn is equals to 5n, remember, that's the constant difference of 5, multiplying with the term number, and we are going to subtract 1 as we've discovered from these 2 examples. And if we are asked to work with bigger numbers, we can quickly now say it. So if I fill out my rule here, which is 5n minus 1, if I have the 20th term, that's going to be 5 multiplied by 20 minus 1. What does that give us? Yes, you are correct. It is 99. And if I say 5 multiplied by 30, and then we subtract 1, what is the answer going to be? If you have 149, you are absolutely correct. And then the last one, if I say 5 multiplied by 100, and then we subtract 1, our answer is going to be 499. If you have the same answer there, well done to you. Let's quickly go to an ad break, and then we'll see you just now.